Welcome to our course of Seismic Stratigraphy. In this course, we will learn some important topics on how to interpret seismic data and to correlate these data with the geologic data. First of all, we need to know what does it mean seismic stratigraphy. Seismic stratigraphy, from its name, it can tell that we are looking for strata, but using reflections, simple and easy like this. So we just extract information from the seismic data that we send into the earth and receive it back using the geophones, and after processing you will have something similar to the geologic section. So it's just getting information from underneath, from inside the earth, and it's just extracting information from seismic data. Seismic stratigraphy also is basically a geologic approach to the stratigraphic interpretation of seismic data, as we mentioned before, and it allows us to direct apply our application to apply the geologic concept based on physical stratigraphy. So the key here is the seismic reflections. We will be all the time playing with seismic reflections to see how they can help us detect specific structures below the surface. And the seismic reflections generated by physical surface in the rock. All of us know what does it mean, physical surface in rock, like, of course, like strata surface, like unconformities, like velocity density contrasts. The velocity density contrast create those kind of reflections. If you have a high density velocity contrast, you will have very good signals or reflections coming back from down. So the seismic section is a record of chronostratigraphic. Chronostratigraphic means something related to age, time, seconds, minutes, depositional and structural patterns. And this is the main key. This is the main difference between the seismic section and the geologic section, as we will see later. Because seismic reflections follow chronostratigraphic correlation, it is not only possible to interpret the post-depositional deformation, but we still possible to make the following types of stratigraphic interpretation from geometry of seismic reflections correlation. Pattern like geologic time correlations, definition of genetic depositional units, thickness and depositional environment of genetic units, burial history, relief and topography of unconformities, and paleogeography and geologic history. So this is a simple definition of seismic stratigraphy. Let's go in depth and see how many groups we have in stratigraphy. Seismic stratigraphy is often divided into groups. Number one, seismic sequence analysis. Seismic sequence analysis. And in this part, there is a separation or separating chronostratigraphic units using unconformities. So the unconformities here is the key. Not only unconformities, but also the changes in seismic pattern. So this type of seismic stratigraphic study depend on separating chronostratigraphic units using unconformity or changes in seismic pattern. Second, seismic facies analysis. And in this part, they will be estimating the positional information using character of seismic reflection. In this part, we use the characters of seismic reflections, how these reflections characterized, and we use those characteristics to define the deposition or depositional environment. Third and last one is reflection character analysis. And from its name, you can tell it's analyzing lateral variation of an individual reflection unit. So you have one reflection unit and you follow it to just study the character analysis of this specific reflection of unit or units in order to localize where stratigraphic changes are found and identify their nature. Okay, so now we will study the seismic profile. All of us know from our study in the first grade the geologic profile. And geologic profile is just representing the structure of the earth horizontally measured in meters, for example, or kilometers or centimeters, and in depth also same units, meters or kilometers. So how about seismic profile? Seismic profile here consists of gather of seismic traces. You know what does it mean, seismic trace? Seismic trace is a record of one geophone, one station. Okay, usually at the top of the profile of this seismic profile, the shot point numbers are located. So you will see in the next figure, you will see the shot point numbers are located, and at the vertical part of this section or this profile, the depth scale. But be careful here, the depth scale is not measured in meters or centimeters or kilometers. It's measured in seconds, and we call it TWT. TWT here means two-way travel time, and two-way travel time of our wave, of our beam. So the wave is traveling from the source down to the specific interface and reflected back to the geophone in what's so-called two-way travel time. So if this wave is traveling to the interface in 2 seconds, you will receive it in 4 seconds. Okay. So on the paper of this section, you will find something called header on the top. It's found either on the right or left part of the section, giving information of horizontal scale acquisition and processing of the data. Sometimes you find the name of the company and the acquisition method and the scale, and very important information at the header. This here you can see all these vertical small lines you see here. If you can look at this very carefully, we call them traces. You see the numbers at the top starting from the right, for example 8350, then 8400, then 8450. So we have like 50 traces between each two numbers here. So imagine how many traces we do to get this figure or this stack, this profile. And of course, if you look at from like a distance, you will see like layering and something like geology there, bedding layers. Okay, this is another example, and if we look at the depths, can be calculated. The depth or the thickness of any specific layer can be calculated when the velocity of geological layers are known or estimated. And here we have to think about what makes this calculation difficult. If we have or if we know the velocity of the media and we receive the signal back, so we have the time, So you know the velocity and the time. And all of us know that multiplying velocity by time gives us distance. So simply we can say that we can calculate the thickness or the depth to the specific interface. Actually, this is partially correct, but not all the time, because within one layer, a specific homogeneous layer, this is okay, because the, the path or the ray or the wave will travel in equal velocity all over the layer and will come back without any problem. But if you have several layers, each of them has a specific or different velocity, you'll have a problem. And then you have to go and use different kind of velocities like interval velocity, average velocity, and these different kind of velocities. Let's see the simple model here. 0, 0.1, 0.2. These are the seconds or milliseconds for receiving the signal from the interfaces. So the depth equals velocity times TWT, two-way travel time divided by 2, and we all know why we divide that by 2. Velocity of water, for example, here is 1470 meters per second. So we have the depth and velocity. Sorry, we know the depth equals velocity by time, and we have the velocity. Then we have the depth to the seafloor, which we considered here as a layer, is 0.2 second. Two-way travel time, and we have to keep that in mind all the time. So the depth or the thickness of this layer is or equals velocity 1470 meter per second times 0.2 second over 2 equals 147 meter. So this is easy calculated because the water is, there is a homogeneity in there. We have no problem. All this layer or this depth, the wave will travel in equal velocity in all of this layer. Okay. Next time we will be talking about the nature of reflections, the nature of seismic reflections, and for now we will know only what are the limitations of seismic tools. Limitations mean in which areas that seismic tool will not help us so much. And if we think about that, you will see critical lithological changes normally take place through vertical distance. As long as we travel in depth, we have a lot of changes in lithology. And those changes sometimes change very fast, which means the bed could be very thin and even thinner than the wavelengths. And if this happens, so the seismic method will not help, because the seismic method can estimate the thickness of the layer, which is more than the force of the wavelengths. Therefore, a stratigraphic succession that would be subdivided and described in outcrop section or in a well log is beyond the resolving power of the seismic tool, as I mentioned. Unconformities and strata surfaces can be detected by seismic surveys, but provided there is a sufficient velocity density contrast across them. You see this beautiful figure tells you that how seismic method using the seismic reflections can give us a very nice picture, almost like the geologic section. Okay, Next lecture, we will be continuing talking about the nature of seismic reflections. And for today, thank you and see you later. Bye.